All right, AP Psych warriors. Our last areas of the brain that we want to be familiar with in the context of this unit have to do with specialized functions related to language. And some of these areas you were actually introduced to in our previous unit as we addressed acquisition of language in children and some of the theories related to language development. So we're already actually familiar, at least vaguely, with Broca's area and Wernickes area because they were presented in Module 36 of your text. But we're going to add to your repertoire a little bit in terms of how your understanding of how different areas of the brain are involved in handling language tasks. And I think in part, it's not just because we're not just introducing this because it's important to know like how language works within the brain, but this is also a perfectly elegant example of how something within an ability that seems very fluid, like it's one thing. It seems when we experience language that it is one thing that's happening. We're speaking, for example, or we're, in this case, reading aloud from a textbook, maybe in class. And it seems like that's one process. But when you look at what's actually going on in the cortex to create it, it's a complex sequence of processing activities that gets subdivided into very specialized component parts. So we're going to take the example of that reading a textbook aloud in class. Maybe this was something that perhaps you did in middle school when you were reading a novel together. Maybe you took turns reading out loud off of a page. Or as an instructor, sometimes when I have to read directions to people, I might be reading something directly off a piece of paper or a screen in front of me. So when I'm doing that, there's actually several things that have to happen in sequence. In fact, this diagram doesn't even handle the first of them. Of course, first, our eyes have to be able to see and respond to light wave information that's coming off the page that stimulates specialized photoreceptor cells in the back of the eye, and that information is transmitted via the optic nerve to the thalamus. If you remember back to our first entry into lower level brain structures, the thalamus actually sits in the center of the brain. It's the brain sensory switchboard, so that's going to relay the visual information from the optic nerve back here to the visual cortex that's located on the occipital lobe. Now, when that information from the words on the page arrives at the occipital lobe, all that your occipital lobe is capable of doing is locating boundaries between like maybe the black print and the white background, the general shape. Like it's just responding to this as visually presented information. It actually takes other steps in order to transform that into something that we might link to language. So the visual messages that are sent in terms of the black and white squiggles that make up the letters, that information about the patterns of the visual is sent to an area on the back of the parietal lobe here, or an area of the parietal lobe, called the angular gyrus. The job of this area seems to be to link visual information to sound inputs. So seeing a word presented and then knowing what it sounds like in your head may be a job that this is important for. In fact, you may notice your angular gyrus kind of struggling sometimes if you've ever been reading a book and like a character has a name that you can't mentally pronounce. So like every time you're reading it, even though you're not reading it out loud, it becomes clunky. You kind of keep tripping up over it. And it's in part because you can't really hear or you can't transform that visual stuff into sound very well. So if you're like me, you just rename that character like Scott or something and refer to him by some generic name that's easy to remember through the rest of your book. Or you do the right thing and like get official pronunciation, but maybe it's not that important for you to do that. Okay, so once that information has been transformed into sound information, is then relayed to this area that we were introduced to a little bit before called Wernickes Area. This is an area of the brain that is named for the researcher who tends to get credit for discovering it, a researcher named Carl Wernicke. And Wernickes Area seems to be very important for comprehending language, whether it's spoken language that you're hearing, or in this case, language that you're reading and then have to kind of transform into something that you're mentally hearing in your head. So if you have damage to Wernicke's area, we call that Wernicke's aphasia, because again, aphasia is just a generic term for any kind of language impairment that results from brain damage. And here we're actually going to take a look at a short video clip that gives you an illustration of what Wernicke's aphasia tends to look like. We're going to see a gentleman who seems to be very confused about the meaning of other questions that he's being asked by the clinicians who are working with him. And he also seems to be unable then to produce meaningful language. So he can certainly pronounce words precisely. So it's not the production of language that's impaired. It's the fact that it's incomprehensible. It lacks meaning, and other folks would have a really hard time understanding it.
Hi, Byron. How are you?
I'm happy. Are you pretty? You look good.
What are you doing today?
We stayed with the water over here at the moment and talked with the people over them over there. They're diving for them at the moment. They'll save in the moment. He'll have water very soon for him. With luck for him.
So we're on a cruise and we're about to
We
get
will
to June.
sort it right here and they'll save their hands right there for them.
And what were we just doing with the iPad?
Right at the moment they don't show a darn thing.
With the iPad that we were doing. We, like here?
I'd like my change for me and change hands for me. It would happy. I would talk with Donna sometimes. We're out with them. Other people are working with them.
Okay, so from taking a look at Byron's case, you can see exactly what Wernickes aphasia looks like. This is a person who's really struggling with language comprehension, and then producing comprehensible language himself. In the case that we were looking at, this was a patient who had suffered a stroke, and that often is the source of both Wernickes aphasia and Broca's aphasia in individuals. And one of the things that I failed to mention to this point is actually there's a reason that we're looking at the left hemisphere when we're talking about these language structures. So we have someone that's facing this direction, so we are looking at the left side of their brain. For the vast majority of individuals, all the language structures or language-related areas of the brain are located in the left hemisphere. So someone who suffers a stroke to their left hemisphere is much more likely to lose language abilities as a result of that. Strokes to the right hemisphere, although they may produce other types of impairments, aren't as often likely to damage language areas. And the trick that people tend to use to remember that specialized function of the left hemisphere is left language. They both start with L. So it can be a handy trick. So another brain area that we encountered during our last unit is Broca's area. Broca's area is involved in productive language capacity because it actually relays messages to the motor cortex here, the very back part of the frontal lobe. As we looked at when we explored the cerebral cortex, this is an area that's involved in directing the activities of the opposite half of the body. So the messages that the motor cortex gets from Broca's area tell you how to move your mouth and tongue in order to make the precise sounds that are involved in speech. And as you might guess then, individuals with Broca's aphasia have a really difficult time producing fluent speech. So we're going to look briefly here at a patient who's suffering from Broca's aphasia. We're going to see some real struggles producing words in the fluent fashion.
No good. Ache and knees and ankles.
Okay, so in that patient, what we're seeing is real lack of speech fluency, and that is typical when we look at Broca's aphasia. So people who experience damage to that area tend to have a real hard time producing fluent speech, so it might be garbled, or it might be they just have a really hard time coming up with the words themselves. Broca's area is actually named for an early neuroscientist named Paul Broca, who got credit for discovering this after he worked with a patient that could really struggle to speak, and the only word that he could say was tan. So he'd repeat the word tan over and over again in place of words that he did not have. And when Tan passed away, Tan, I should mention, also had paralyses on the right side of his body, which is consistent with like left hemisphere damage, especially near the motor cortex. When Tan was autopsied, there was huge lesions to the area, including what's now known as Broca's area and his motor cortex, that did explain his functional difficulties with language. So this concludes our tour of the areas of the brain involved in language impairment. So if you feel like you've got all your diagrams updated and that you've mastered your understanding of these various brain parts, you can go ahead and test your abilities using the quiz and perhaps move on to constructing your own model of the brain. Good luck!